Okay, in this presentation we're going to look at ranges, which are a very important object in Julia, a type of data type, and also the LinRange command. If you're familiar with sequences in R, or as they might be called in Python and MATLAB, ranges, this is what we're talking about. Also, if you're looking or if you're interested in a command called linspace from Python or Julia, in Julia, Python or MATLAB, in Julia it's called linrange. It used to be called linspace, but then they just aligned it with the idea of ranges, so it's called linrange here. So let's begin. I'm briefly going to use the linear algebra package, so I'm just going to run that just for one little thing. I'm not going to talk about it too much. So essentially, there's a bit of notation here used to set up a sequence there. So I'm just going to start off with the top one there, okay? And essentially what we have there is the lowest value, the floor essentially, the step size, and the ceiling, the maximum value, okay? Now there's an important sort of clarification here for the behavior of this, and we'll talk about it on an ongoing basis, okay? So as we have it there, you can ignore that second line there. As we have it there, what that should give us is a range of values there which are increasing in unit steps of 0.1, which is the step size. And it goes from the minimum value to the maximum value. Okay? So let's run that there, and that is what that would look like. It seems like we just got it doesn't really come across intuitively there, but let's see what the maximum value is. Okay, 1.0. Okay, now those are floating points, so just what I'm going to do here briefly is just see if we can do that for integers and see what happens. Same sort of thing there, maximum there is 5. So that's it. That's a very sort of simple idea about the idea of ranges there. Okay. Now, something to look out for is if the maximum is not a multiple of the step size. Okay. So let's look at this example here, which is very similar to one we just used. 0.0 and is the minimum. The maximum is 1.0 and the step size is 0.15. Now, a little bit of mental arithmetic will tell you that goes 0.0, 0.15, and then 0.9, but the next value according to the step size would be 1.05, which is above our maximum. So what happens here? Okay, so let's just have a look at that and see what happens there. So that gives us a range of values from 0. The increment each time is 0.15, and the maximum value of the range is 0.9. So that's not actually the max value we set. So the max value is like a ceiling, okay? Maximum of A, is that equal to the max value? No. What is the maximum? 0.9, okay? Now, as with other objects, other types, a range can act as a vector there. Now, I'm going to do something interesting here. If the step size is, you want a step size of 1, you don't actually have to specify the step size. Okay, so we have a minimum here and a maximum there. Okay, but we're not specifying our step size. Let's just run that. 1 to 10. And see how that works there for us. 3. Okay. And let's look at the type of that. What is the type of here? It's a unit range of integers. Okay. So let's just sort of run that again, see what happens just when we specify. You notice this has changed. Okay. But that didn't change, and the step range there changed. So what's the difference there? It's essentially a unit range is essentially a type of step range, but just with obviously the step size there is 1. Okay, that's all. So you just watch out for those two, the difference in types there. Okay. Likewise, I'm going to do something similar here. Our minimum value is 1, the increment is 0.5, and the maximum value is 4. So let's just run that. 1.0, step size is 0.5, and the maximum is 4. The second value there would be of the Second value would be 1.5. Okay. And what is the type of that? It's a step range length. Essentially, the only difference to what we've seen here before is that essentially it's sort of creating that in terms of real numbers, floats, essentially. That's all. Okay. You can convert it to a vector if you want. Okay, unit range. But it doesn't, doesn't necessarily mean you should. Okay. Sometimes it's handy, but anyway. So that's it created as a vector. If R people who use the R programming language might be familiar with that. Now, our little trick with linear algebra. I'm just going to reset everything here, partly because I just changed things so much on the fly that I have to just stay consistent. So, just recalling the using linear algebra, and I'm just resetting A to be 1 to 5 there. So what we're going to do here is set up a diagonal D. Let's have a look at that. That's why we have linear algebra there, just actually so we can use that command diagonal. That comes from the linear algebra package. A is 1 to 5, and essentially what we're going to do there is multiply our range by our diagonal. Okay, so A star D. Did I get that right? No, I didn't, because it should be D star A. There we go. Essentially, it's turns into a vector there. Okay. Just to sort of the point there is just to actually show that you can multiply them out, matrices and so on. If we want to reverse our sequence to a countdown, okay, essentially just put a reverse around it. What we can do here is experiment a little bit, but just actually see what we need. There we go. 10 to minus 1 to 1. Okay. Let's see, does that work for us? Without using the reverse command. So it's a countdown, the start, the finish, and the increment, or the decrement here, probably. There we go. And what does that mean for us here? 5. Okay. So if you're counting down, just put in a step size, a negative step size, essentially. Okay. Let's break it, see what happens. 514. Don't know if that makes any sense. It doesn't. Okay. This sort of looks like it might make sense if you're not familiar with it, but when you try it out, it makes no sense. It doesn't work. Okay, so let's put that back the way it should be. All right. Now, if you want to actually specify how many points should be in it rather than the step size, essentially what you do is just spell out the command as length. Okay, so here we have 1.0 and 0 and 1.0 as our maximum and minimum values, and we have our number of points there, and we're going to specify it as range with the additional argument length. There we go. 0.0, our step size is 0.111, and the maximum value there is 10. Okay, now this is more familiar with the linspace command. Here it actually just picks out, determines that there should be 10, and will pick the step size accordingly. Okay, so we can pick that out a little bit, do it a little bit more challenging. Okay, do something more challenging. Let's put something below there. A4, the fourth element, 0.5. Well, actually, that would make sense. A3, 0.33, and so on. Okay, so we don't specify the step size. We just specify the number of values we want, and it will create them accordingly. Okay, so in this case, the maximum value will equal the maximum. Okay. Now, just actually a quick remark on LinRange. It actually works in this. It's very similar to what I just showed you. We have a start position, a start number, a stop number, and a number of elements in the array, essentially a number of points in our range. Okay, and previously that was called linspace. Okay, so in case you're trying to Google it, so LinRange. Let's have a look at that. There we are. 10 element linear range, or LinRange. Okay. From 0 to 2 pi, and it's in increments, or 10 numbers there. Okay. 10 elements. There we go. Just have a look at another one there. This one's a countdown. Okay. In case you're interested. Okay. So again, it determines how many numbers there's, how the step size, and what the corresponding value should be, and so on. I think I made my point there. We have a type there as well. We just check the types. That's always good practice there. So let's just run that. There you are. It's a LinRange. Okay, that's good. We'll leave that there.